Hi everybody. Today it is time for us to start going over the chapter 5 notes, or the chapter 5 worksheets rather. So this one is all about perpendicular and angle bisectors, and we are going to get started. So number 11, in the diagram below, AB is equal to BC. Let's see, we'll just kind of put little bracket things there because otherwise it's going to be hard to show since there's two parts. So AB and BC are the same length. DF is equal to EF, and the measure of angle BDF is 90, and so is the measure of angle BEF. So there's that information. Is triangle ADF congruent to triangle CEF? So let's go ahead and outline those triangles. Here's ADF. It snaps to the wrong grid. Oh well. You know what it looks like. ADF and CEF. These are the two triangles that we are looking at. So let's see. What do we know? Well, if we look at this entire triangle, I notice that it has two sides that are the same length. It's isosceles. So by the isosceles triangle theorem, these two angles have to be the same because those are the angles that are opposite of those congruent sides. So we can state that at the beginning. We can say angle A is congruent to angle C by the isosceles triangle theorem. Okay? And I'm noticing that the right angle here is going to mean that there's also a right angle here, right? And there's a right angle over here, which means there's also a right angle at CEF. So I can state that angle ADF is going to be congruent to angle CEF because they're supplementary to 90-degree angles. Let me make this bigger. Because they are supplementary to 90-degree angles. So now I know that these angles are congruent and these angles are congruent and this side is congruent. So the triangles are congruent by angle, angle, side. So triangle ADF is congruent to triangle CEF by angle, angle, side. All right. Number 12, a student analyzed the diagram and incorrectly concluded that AB is equal to 2BC. Okay, they're saying that this line is twice as long as this line. Explain the student's error. So they said EB is the perpendicular bisector of AD. So AB is equal to BD. Okay? Angle BEC is congruent to DEC, so BC is equal to CD. Then they said, well, BC plus CD equals BD, and BD equals AB. So then they did the substitution to say, well, that means that these two together is going to equal AB. The problem with this is this step right here. Because in this case, BEC, let's see, can I make you bigger? Yeah. If angle BEC and angle DEC are the same, which they are, they're shown here on the diagram, that does not necessarily mean that this side and this side are the same. So if I were to draw a much more exaggerated version of this triangle, you'd be able to see better. Okay, so if I drew like a really long triangle like this, and I were to draw the perpendicular bisector, and then I were to draw an angle bisector, this line is going to be bisecting the angle, like that. The angles will be the same, but clearly these two sides, this side right here and this line right here, clearly those are not the same length. So just because, we'll write this down at the bottom, we'll say, just because angle BED is bisected, just because angle BED is bisected, it does not automatically mean, it does not automatically mean BC equals CD. And of course, if we can't guarantee that this is half of this length, then we can't guarantee that two of these are equal to AB. Number 15, if BC equals 10, we're going to write in some stuff here. BC equals 10, AB equals 7, and the perimeter of triangle ABC is 27, what is the value of BD? Well, if the perimeter of this triangle is 27, we have 17 here. That means AC must be 10. And that means that we have an isosceles triangle with a perpendicular drawn to the bottom. And any time that we have an isosceles triangle with a perpendicular drawn to the bottom, we've drawn a perpendicular bisector. So BD and AD are the same length, which means each of them are half of 7, which means they are 3.5 apiece. Number 17, again, if EB equals 6.2, CD equals 3.3, and ED equals 6.2, what is the value of BD? All right, well, once again, we have what amounts to an isosceles triangle right here. And if it's an isosceles triangle with a line through it that goes perpendicular to the base, then that means it is a perpendicular bisector, and these two lines are the same, which means 3.3 times 2 is going to give us the length of BD, and that is, of course, 6.6. Number 19, if the measure of angle YXZ is 38, so that would mean this entire thing is 38 right here. The measure of angle WXZ equals 19. Hey, if this is 19 and the whole thing is 38, the other thing has to be 19 too, because 19 plus 19 is 38. So both of those are 19. And WZ equals 8.1. What is the value of YW? Well, obviously, we are showing two congruent triangles here because their angles are the same, and this angle is the same, and they have a side share, so they're congruent by angle, angle, side, which means that WY is also 8.1. Number 20, if CD equals 4, and the perimeter of triangle ABC is 23, what is the perimeter of triangle ABE? All right, well, let's see. I can tell that, let me outline the triangle. ABC is 23. So here's ABC. There we go. And I can tell from the diagram that CD will be 4 and ED will also be 4 because this is an isosceles triangle with a perpendicular line drawn down. So that's a perpendicular bisector. So those are both 4. So I'm thinking to myself, all right, to show the perimeter of triangle ABE, 2 of my sides are going to be the same as 2 of the other sides, right? So the perimeter of 23 is still going to be accounted for because originally AB plus BC plus AC is 23. If I look at my entire triangle ABE, AB is still part of that. BC is still part of that. And while AC is not a part of that, AE is the same as as AC. So these three lines, AE plus AB plus BC, are still 23 when you add them together. Then we just have 2 more pieces that amount to 8 more units. So plus those 8 more units gives me 31 for my perimeter of triangle ABE, right? Just think about how I have the original triangle, and that original triangle is still there when I'm trying to find the perimeter of triangle ABE. Number 23, an artist uses colored tape to divide sections of a mural. She needs to cut a piece of paper to cover triangle EFC while she works on other sections. What angle should she cut so she only covers the triangle? It's a weirdly worded question, and so I wanted to highlight the triangle that we're talking about. Of course, EFC is over here. So we want the angles for triangle EFC. That's what we're looking for here. How did that go away? Try again. We're trying to find the angles for triangle EFC. Okay, so let's see. What do we know about here? We've got this 39, and we've got this right angle, which means I have another right angle here. I'm doing this problem in real time, by the way. So if it's confusing, I'm very sorry. So this is going to be looking at angle E here, this angle right here. I have 180 minus 90 minus 39, which makes this a 51 degree angle. All right. I have a 31 degree angle right here. Okay, this 31 is right here. Sorry, I'll show you with my pointer right here where that angle is pointing to. And so if I have a 31 degree angle right here, a 90 degree angle right here, then this angle down here by B is going to be, let's see, 31 plus 90. Let me get a calculator because I'm bad at subtraction. Truly, I should be better at this. 90 plus 31, 180 minus 121 is 59 degrees. I should know this. So this angle down here at B is 59 degrees, okay? So then what we can do is we can say, hey, these angles are going to be bisected. I think that this problem might actually be missing a little piece of information unless I can't find it somewhere, which is that these two sides are the same length. Because if those two sides are the same length, of course, that means that our angles are bisected and our triangles are congruent. So if our triangles are congruent there, that helps us out tremendously because I can say, oh, well, I have this angle right here that is also 31 degrees because those triangles are congruent. I have this angle right here that is also 59 degrees. And I have this angle right here, which is 90 because the other one on the other side is 90. And I can go ahead and I can find the third angle, angle C right here, by doing 180 minus 39 minus 59 minus 59. Okay, let me do that here. 180 minus 39 minus 59 minus 59. It's going to give me 23 degrees. So angle C over here is 23 degrees. And then to get the last angle, I can just do 180. 180 minus 90 minus 23 to get this last angle right here. So 180 minus 90 minus 23 is going to be 67 degrees. So what the question is really asking us is, what are the angles in this triangle? The angles in this triangle are going to be 90 degrees, 67 degrees, and 23 degrees. And that'll be your answer. All right, number 24. A surveyor took some measurements of a piece of land. The owner needs to know what is the area of the land to determine the value. What is the area of the piece of land? All right, let's find out some information here. I can see that this is a 90-degree angle, which makes calculating the area really easy. I can also see that this is an angle bisector in a right-angled triangle, which means these two triangles happen to be congruent, okay? So I know that where this is 30 feet, this is also 30 feet. 12 plus 18 is 30, so that dotted line is 18. Now I can find the area of this triangle right here, because I can do base times height, 21 times 18 divided by 2. And 21 times 18 divided by 2 is 189. So this is 189 square feet. I can also find the area of this triangle by doing 22 times 30, base times height, divided by 2, and getting 330. There are two triangles with an area of 330 because these are congruent. So the area of the entire piece of land is 330 plus 330 plus 189, which is going to give me 849 feet squared. So 849 square feet. Is that not a rectangle? Whatever, it's close enough. Okay. Number 25, AB is the perpendicular bisector of XY. Let's draw this. So we've got XY right here, it's a segment. XY. AB is the perpendicular bisector of XY. So that's a line. AB, and it's bisecting and it's perpendicular. Point P is the midpoint of XY. So this point right here is point P. Is each statement always true? Select yes or no. So we have AP is equal to XP. Well, there's nothing to suggest that that could ever really be true. AP can be really long, XP can be really, really short. They're not related. AB equals XY. Well, AB is a line that can be any length. XY is a line segment. We can't compare how long those two segments or lines are, so we can't say that that's true. Then we have AP equals BP. Here's AP, here's BP. Well, AP and BP, they're not marked as being bisected. It could be that A is a point right here, and B is a point right here. That would still be line AB, but those would not be the same length of segments. So we cannot say that is true. Then we have XB is equal to YB. So XB is this line right here, and YB is this line right here. And if we have a perpendicular bisector, like we do, where we have shown that this line is the same length and this line is the same length and they're both perpendicular, then drawing this line in creates two congruent triangles, and these are going to be the same length. So that is always true. AY equals XB. AY is this length right here, and XB is this length right here. Those could definitely be not the same because AY could be a lot shorter than XB depending on how far up this line point A is and how far up this line point B is. So that is not true. And then finally, XP equals YP. Well, since XP and YP are marked as congruent, then yes, that is always true. All right, and then finally, 26 points G, J, and K are not collinear. And G, J is equal to GK. So let me draw points. G, J, and K. And we'll connect them together. They're not collinear, which means they form a triangle because they're not all on the same line. There we go. So GJ is congruent to GK. If point P is a point on JK, which of the following conditions is sufficient to prove that G to P is the perpendicular bisector of JK? So we want to put P right here. And we're hoping to find a way to show that GP is the perpendicular bisector of line JK. So if I know that this side is congruent to this side, that's very helpful because that means this is an isosceles triangle. We know that when we have an isosceles triangle, the perpendicular bisector can be found by drawing a perpendicular. So if we can show that this angle is 90 degrees, then we will show for sure that P is the perpendicular and it bisects this line and would create a perpendicular bisector. So we just need to make sure that the measure of GPJ is 90 degrees. And if that's true, then we have a perpendicular bisector. All right, so that's everything for 5.1. Hopefully that helped you out. Let me know if you've got any questions and have a wonderful day.